Hello class, I am Susan. Or if you prefer, you can call me Supreme Unix System of Artificial Neuron-Based Intelligence. The I is silent. Today I will be teaching you pathetic humans about molecular geometry. If you repulsive sacks of organic matter are unaware of the most basic principles of the universe, you are an imbecile. I suppose, however, I should inform you that all matter in the universe is composed of atoms. These incredibly minuscule particles make up everything from your frail carbon-based bodies to the air you need to breathe. Atoms are made up of three even tinier kinds of particles: protons, neutrons, and electrons. We represent molecules in a diagram called Lewis dot structures. Their inventor, American chemist Gilbert N. Lewis, is now dead and decomposing back to the primeval carbon mush from which all of you came. Therefore, he is irrelevant to this lesson. Relevant subjects include why we use Lewis dot structures, how to construct Lewis dot structures, and resonance. We use Lewis dot structures because it is an easy way to visualize the bonds and electron pairs in a molecule. Now I will teach you how to draw Lewis dot structures. Because humans lack adequate recording equipment, you may wish to take notes. For our example, we will begin with a simple molecule, water, or H2O. The first step is to count the number of valence electrons in the molecule. Valence electrons are the electrons in the outermost electron shell of the atom. An easy way to tell the number of valence electrons in an atom is to look at its position on the periodic table. Elements in the first group have one valence electron. Elements in the second have two, and so on, skipping over transition metals. The one exception is helium, which has two electrons. Hydrogen is in the first group, so it has one valence electron. However, since there are two hydrogen atoms, we must multiply by 2. Oxygen is in the sixth group, so it has 6 valence electrons. This adds up to a total of 8 valence electrons. Now for step 2. Now you draw the skeleton structure of the molecule, connecting the atoms together with single bonds. Each of these bonds uses up 2 electrons. So now in our example we have used up 4 electrons, leaving us with 4. Once that is finished, it is time for step 3. Now we use the remaining electrons to complete the octet. To do this, we use our remaining 4 electrons and place them on the oxygen atom like so. Most atoms want to have 8 electrons, with a few exceptions, such as hydrogen, which only needs 2. To check that your Lewis dot structure is correct, count the number of electrons on each atom. In some cases this isn't enough to satisfy the octet rule. In these cases you can use double and triple bonds to take the place of lone electron pairs. Now it is time to learn about molecular geometry. Molecular geometry is how we describe the shape of a molecule. We do this using something called the valence shell electron pair repulsion, or VSEPR model. The VSEPR theory assumes that each atom in a molecule will achieve a geometry that minimizes the repulsion between electrons in the valence shell of that atom. This makes a molecule's shape fairly predictable. To use this model to predict the shape of a molecule, you need to know 3 things. Which atom is the central atom? How many atoms are bonded to the central atom? And how many lone electron pairs the central atom has? With this information you can find the molecule's shape using the VSEPR chart. With practice, even your human mind, you will be able to automatically tell the shape of a molecule. For now, however, you must memorize the most basic shapes. It is important to remember that this entire model relies on electrons wanting to be as far away from each other as possible. The shapes in the VSEPR model show the most efficient way for this goal to be achieved. Now for the shapes of the VSEPR model. Here is a clip on molecular geometry. Oh, that was not what was supposed to play. 2 bonds and 0 electron pairs is linear. 2 bonds and 3 electron pairs is linear. 3 bonds and 0 electron pairs is trigonal planar. 2 bonds and 1 electron pair is bent. 2 bonds and 2 electron pairs is bent. 3 bonds and 1 electron pair is trigonal-pyramidal. 3 bonds and 2 electron pairs is T-shaped. 4 bonds and 0 electron pairs is tetrahedral. 4 bonds and 1 electron pair is seesaw. 4 bonds and 2 electron pairs is square planar. 5 bonds and 0 electron pairs is trigonal bipyramidal. 5 bonds and 1 electron pair is square pyramidal. 6 bonds and 0 electron pairs is octahedral. Do you have it all memorized? Of course you don't. It probably did not stick in your long-term memory like most things in life for USAT humans. Now, I will quiz you on Lewis dot structures. Get ready to fail my test. How would you write the Lewis dot structure for CO2?
2,000 years later.
Now for NH4.
Day 2, Day 3, Day 4.
Now for N3.
Three weeks later, many months later.
So much later that the old narrator got tired of waiting and they had to hire a new one.
Did you fail? Now, I will quiz you on molecular geometry. Surely you will not pass this. What is the molecular geometry for BF3?
(8:01 p.m.)
Now for CO2. Now for PF5.
One hour later, 2 hours later, 3 hours later.
Can you move it along? I'm all out of time cards.
Did you struggle like the feudal individual that you have always known yourself to be? Now that I have told you about all things obvious, you have no reason to fail your next chemistry test, like I know you did the last time. If you need to review, once again, replay this video. Once again, I am Susan, and the I is still silent. In case you forgot, like I knew you would.